not week 8. This is like day 8 of the 30-day LeetCoding challenge. And the question for day 8 is it's like one of the popular question, and it's not. I think this difficulty is easy, and and the question is called middle of the linked list. So let's go ahead and read the detail of the question. Given a non-empty single linked list with head node, return a middle node of linked list. If there are two middle node, return the second middle nodes. So for this example, we want to return 3 because 3 is like in the middle. That makes sense. So we want to return the nodes, not number 3. This is actually a linked list structure. It's not a list. It's not an array. It's a linked list. And this is also a linked list. And in this case, the middle is right here. So since the middle is right here, we want to return the second one. So it's either 3 or 4, but we want to return the second one. And there are like multiple ways of doing this question. Like one way is we traverse through the whole linked list to find out how many elements are there in the linked list. And once we figure that out, so like for example, let's say that this is our linked list. So we go through and we found out that there are like six nodes. So what we want to do is we want to divide this by 2 and add by 1. So we will get 3, and then should we add 1? Let's see. So in this case, we want our linked list to go 1, 2, 3. Yeah, we want to. So this is 4. I don't think we need to add 1 because we want to go 1, 2. We want to traverse like 3 times. And in the case that we have like something like this, so for this case, we traversed through the whole linked list, and we found out that there are like 5 elements. So it's divided by 2. This is like floor division, so we should get 2. So we want to traverse 2 times to the middle. So that makes sense. So that's one way of doing that. Like first figure out how many nodes in a linked list. Second way of doing that, we can kind of have like two pointers. So one pointer like point to here. Let's say pointer A and B. So pointer A point to 1 and pointer B point to 2. And then pointer A is move only like one step, while pointer 2 and move like 2 steps. So in this case, it's starting like this, and then the next time this pointer will go out of boundary. So when it go out of boundary, we want to stop, and we want to move this one forward all the time. And it's also the same when we have a like even number of linked lists. So initially A was right here and B was right here, right? And pointer B moved 2 nodes, always moved 2 nodes ahead, and this pointer A always moves like 1 node ahead. And like the second iteration, this pointer will go out of boundary, but we still want to increment A. So after we go out of the loop, we want to increment A every time. So let's do the second one, because the second one is slightly faster. It's only like traverse like 1 time, while the first solution you need to traverse twice. You need to traverse to the whole thing, and then you get the delay, and then you traverse like half of the way. That's not what we want. Alright, let's do it. Let's code. So let's see. So we can say abbreviate of slow is equal to head, and and uh, and fast is equal to slow dot next. So this would so initially we want to start it right here, A and B. Then we want to have a loop while fast dot next. So we want to check fast dot next first. So if fast dot next is not null, and fast dot next is not null, then we want to increment our fast to uh, fast dot next, and this would be not null, and then we would increment our slow by one step, and then like later on we always have to increment the slow no matter what. So even though like we have to say like two nodes, one's the B is like the fast, so one it's like go out of boundary. We want to increment A to here for the final answer. So what we can return, we can just like return slow down next like this. So will this work for one nodes? I don't know, like what is the middle of a one node? It will work for two nodes because like I showed earlier. So we have A and B right here, slow and fast, and then this will go out of boundary, and then slow down next we'll point it to right here. I'm not sure. Like what should we return if we have just like one node? Let's run this first and see if we pass the general test cases. So we pass it. So what if we have only like one node? For my code, it's going to return none for sure. Runtime error. So it assumes that the test case never have so if fast dot next is equal to none, we want to return none. I got an error because fast right here is none for the case that we have only one node, and fast so slow dot next is none, right? And then I try to access none dot next. That's an issue right there. If fast is equal to none. Oh, I'll return 1. So return slow. There we go. I think it should work for all the cases. Yeah, it's accepted. Alright, thank you everyone for watching, and if you guys have any questions, feel free to leave down a comment under this video. Thank you. Bye.